Welcome back to our third session of If God Made the Universe. Today we're taking on a dark subject, darkness itself. And I'm absolutely certain that you will come away from this session with insights you never imagined about what the Bible and science have to say about the concept of darkness. Dr. Ross has already shown us that the universe is exactly the right size and exactly the right age to support advanced life. But what role could darkness possibly play in the grand scheme of human existence? Time to get out your notepads and enjoy session number 3. If God made the universe, why is it so dark?
If God made the universe, why is the universe so very dark? This is the third riddle we're going to tackle about the characteristics of the universe. What is darkness? Now, for millennia, the standard textbook definition, and I was taught this when I went to school in college and university, is that darkness is the absence of light. However, if we look at the Bible, we see a different definition for cosmic darkness. It's in the oldest book of the Bible, Job 38, verses 19 and 20. Where does darkness reside? Can you take it to its places? Do you know the paths to its dwellings? And what's interesting here is in the book of Job, it's telling us that darkness is a substance, not just the absence of light, but an actual substance, and that it has geographical locations. Well, thanks to discoveries made in just the past few years, we know that the textbook definition was incomplete, and that Job in the Bible had it right all along. We now know that darkness is a real substance. In fact, it's a combination of substances. That the dark stuff of the universe has 3 components: dark energy, exotic dark matter, and ordinary dark matter. Now, we also know the proportions. We know that dark energy makes up 72% of the stuff of the universe, exotic dark matter 23%, and ordinary dark matter about 4.4%. Now, you say, what are you talking about? Well, ordinary matter is the stuff we're all used to. Protons, neutrons, and electrons. It's what our bodies are made up of, it's what our planet is made up of, our solar system. It's composed of this ordinary matter. But we now know that the universe contains 6 times as much exotic matter as it does ordinary matter. The difference is ordinary matter strongly interacts with light, or photons. Exotic matter does not. You may have heard this term, WIMPs. That's an acronym that stands for weakly interacting massive particles. Particles with mass that weakly interact with ordinary matter, and in particular with photons and light. In fact, some of these particles don't interact with light at all. And one of these WIMPs can literally pass through the entire planet Earth without interacting with anything in the Earth. And then this dark energy is something we talked about in the second session. It's the energy that's embedded in the surface of the universe. And let me remind you again, all the physical reality of the universe, all of its matter, energy, space, and time, is encased in the 3-dimensional surface of the 4-dimensional expanding universe. And if we add up the totality of all this dark stuff, it comes to 99.73% of the total content of the universe. So you look at those stars and galaxies and planets and burnt out stars, that's only 0.27%. The vast majority of the universe is made up of darkness. And we also know that the darkness has specific geographical locations. Just in the last couple of years, we've been able to actually pinpoint where these 3 different kinds of darkness reside. Each one has a different locale within the universe. And it's this dark stuff that controls the cosmic expansion. This is what determines how rapidly or slowly the universe expands at different points throughout cosmic history. We also now can measure the quantities of the 3 different kinds of darkness and the geographical locations. And as we do that, we discover that each one of those 6 measurements shows exquisite fine-tuning. In fact, if you were to ask me as a scientist, where in all the sciences do we find the most spectacular measurable evidence for supernatural, superintelligent design of the created realm for the benefit of life and human beings in particular, I would tell you it's the dark stuff. The quantities of the three different kinds of dark stuff and the locations of the three different kinds of dark stuff literally must be fine-tuned to many, many, many orders of magnitude greater than the very best possible engineering fine-tuning design that we human beings are even conceivably possibly achieve. Which means that the one that designed this universe for our benefit is many, many orders of magnitude more intelligent, more knowledgeable, more creative and powerful than we human beings. Now, that's the universe. The universe must be very dark. And the three different kinds of darkness must be exquisitely designed, fine-tuned in terms of the quantity and locations so that we human beings can possibly exist. But something else astronomers have recently discovered is that our planet Earth, for two different reasons, must reside in the darkest life conceivable location in the universe. That everywhere else you go in the universe, there's too much light. And so for us to be able to exist and for us to be able to, well, we'll get into this. For two reasons, we have to be in the darkest possible spot where anyone can even conceive that life could possibly exist. One of the things we notice about our planet is that there are no nearby bright planets to our planet Earth. 8 planets in our solar system now that Pluto's been officially demoted. And we do see some bright planets. Jupiter's bright and Venus is bright. But it really is amazing that we do not have a brighter planet in the nighttime sky. For example, if you were to have Mars and Venus trade places, as it is, where Venus is, when it's at maximum brightness, you can read a newspaper by its light. But if we were to have it switch places, we now would have Venus farther away from the Earth than the Sun is. It would dominate the nighttime sky and make it very difficult for us to do astronomical observations in terms of looking at very dim galaxies. And so we are blessed with the fact that we have the planets we need for life, but none of them are so close to us or so bright that it would disturb our orbit. I mean, if you had Jupiter where Mars is, we'd be in real trouble, because now its gravity would begin to disturb the orbit of the Earth. By the way, if you have it farther away, we'd also be in trouble, because if it was farther away, we wouldn't get adequate protection from the gravity of Jupiter to protect us from collisions with comets and asteroids. It's also true that our star, the Sun, our solar system, is in a place within our galaxy where there are no nearby bright stars. I mean, here we have a map of all the bright stars within the vicinity of the Sun, and then none of them are very bright, and they're all quite a good distance away, and that helps us in two ways. If we had a nearby bright star, that star would disturb the orbital paths of the planets in our solar system, and that would not be good for advanced life here on planet Earth. On the other hand, if you had that bright star, it would also make it difficult to do astronomical observations of any depth. And then we look at our Milky Way galaxy. What we see is that our solar system, at the present, by the way, our solar system moves around the galaxy. It crosses a spiral arm about once every billion years. But it's been 500 million years since we crossed a spiral arm. And what we notice, first of all, is that we're a goodly distance from the center of our galaxy. Half the stars in our galaxy are what we call the central bulge. And that's also a place where we have deadly radiation. There's a supergiant black hole, for example, the center of our galaxy. And there's also stars that are exploding there, which are throwing out nasty radiation for life. We're far enough away where that's not a risk. And we're also far enough away from the central bulge where that light of that bulge doesn't prevent us from doing deep astronomical observations. If we were any closer to the center of the galaxy, the nighttime sky literally would be too bright. And as I mentioned, we cross the spiral arm about once every billion years, but now we're halfway between the Sagittarius and the Perseus spiral arms, which means we're in the darkest possible spot relative to the spiral arms. Now, That helps us in two ways. If you're in one of those spiral arms, they're gigantic molecular clouds that can disturb the movements of the planets in our solar system. There's also bright stars that are throwing out copious amounts of ultraviolet and X-ray radiation. Fortunately, we're far enough away from the spiral arms where that's not a risk. We're also far enough away where the gaseous nebulae and the supergiant stars that dominate the spiral arms do not present a problem for astronomical observations. And in terms of mentioning the gaseous nebulae, if you look carefully at the slide here, you'll see little pink spots all along the spiral arms of our Milky Way galaxy. Those pink spots are dense gas clouds where new stars are forming. And they can be quite bright. But what we notice is that our solar system is not close to any of these gaseous nebulae. In fact, in the next slide, I'm going to show you the Orion Nebula, which is the closest of these nebulae. And you can see it in the constellation of Orion. You got the 3 stars for the belt and the 3 sword stars that hang down from the belt. The central star is the Orion Nebula. If you look at it in a pair of binoculars, you can see that it actually has a little pink or green glow to it, depending on your pair of binoculars. But our galaxy is atypical. By the way, advanced life is only possible in a spiral arm. A galaxy that's got spiral arms, where the spiral arms are highly symmetrical, just the right distance apart, and the galaxy has to be just the right mass. But as you look at spiral galaxies throughout our universe, these are galaxies that are still forming stars, galaxies that still have these gaseous nebulae, these maternity wards of the universe, if you like. But they tend to be quite large and bright. And what I'm going to do in the next slide is show you a gaseous nebulae in a nearby galaxy. It's only 1/16 the size of our Milky Way galaxy. This is the Tarantula Nebula. And it really dominates the galaxy in which it is, and that's typical of these galaxies that are still forming stars. And what I'm going to do in the following slide is show you to scale a comparison of the Tarantula Nebula with the Orion Nebula, where everything is to scale with respect to size and everything is to scale with respect to brightness. And so on the right-hand side, you have the Tarantula Nebula, and the left-hand side, you have the Orion Nebula. Can you all see the Orion Nebula there? If I tell you where it is, go about halfway up that black stripe and go in a little bit, probably about a third to a quarter of the way, you might see a tiny pink spot. And actually, I cheated a bit. I brightened it up a bit so that you could actually see it on the slide. That's the Orion Nebula. And so it shows you, here's one of the dominant gaseous nebulae in our galaxy compared to a dominant gaseous nebulae in another star-forming galaxy. But look at the difference. And I could present it this way with a thought experiment. What if we were to have the Tarantula Nebula and the Orion Nebula switch places? Now, as it is, the Orion Nebula is a significant distance away from our solar system, 14 to 1,500 light years. That's a long ways away, given how predominant these and numerous these gaseous nebulae are. But if we were to do that, have the Orion Nebula and Tarantula Nebula switch places, now when you go out in the nighttime sky, this nebula, rather than covering an area, say about half the diameter of the moon, would now cover 80 moon diameters across the sky. It would be so bright, you could not only read a newspaper by it, you could even read fine print by it. And it would be impossible to do astronomical observations other than, say, looking at the planets in our solar system or the brightest stars. Everything else, astronomers would be quite ignorant of. And so our solar system resides in the darkest possible spot of our Milky Way galaxy, where life by any stretch of the imagination would even be conceivably possible. Now, it's also true of our Milky Way galaxy. Now, for life to be possible, you must reside in a cluster of galaxies. It's important that our Milky Way galaxy consume a dwarf galaxy every few tens or hundreds of millions of years. And so you have to be living in a place where that's even possible. However, your typical cluster of galaxies in the universe contains thousands of galaxies. And the galaxies typically are quite close together. So if my fists were galaxies, they'd be about this far apart. Our Milky Way galaxy exists in what's called the local group. It doesn't have thousands of members. It contains two medium-sized galaxies, medium-large galaxies, our galaxy and the Andromeda galaxy. Everything else is a dwarf galaxy. About 100 members total, but only two galaxies that are even very large. And rather than being this far apart, they're about this far apart, which means we don't get gravitationally beat up by adjoining galaxies, which is good for life, but it also means that we actually get to see something in the nighttime sky. So here's a small cluster of galaxies, not our own, and you can see in the center there a spiral galaxy. And but what you've noticed, if you're an astronomer in that spiral galaxy, if you look one way, the nighttime sky would be obliterated by a giant elliptical galaxy, and if you looked in the opposite direction, the nighttime skies would be obliterated by the light of a giant spiral galaxy. And there's other galaxies that are in the way as well. There's only little tiny patches of the sky where you'd be able to see anything. And so not only are we in the darkest life conceivable spot in our Milky Way galaxy is in the darkest life conceivable location within the entire universe. So we have this very special location. It's a location where life is actually possible, and it's a location where we can see all of cosmic history, including being able to witness the dim light from the cosmic creation event. We're in such a dark spot in our galaxy and the universe, we can actually see all the objects that take us back through cosmic history, even to the very beginning of the universe. In fact, because we live in such a dark location, we can actually measure the history of the universe all the way back to when it was about a trillionth of a trillionth of a trillionth of a second old. That's how close by observations we can get to that moment when God stepped in and created this universe of matter, energy, space, and time. Now, we've talked about in a previous session how we happen to be at the ideal time when we can see the whole story of cosmic history. Now we recognize we're not only at the ideal time, we're at the ideal location. You know, my colleagues who are astronomers who don't believe in the Christian faith will say sheer coincidence that we happen to be here at the best possible time to observe all of cosmic history. But how can you say it's a sheer coincidence that simultaneously we're at the ideal time in the ideal location? Surely that must be the result of someone purposely putting human beings at the best possible time and the best possible location, which tells us there must be some reason that God wanted us to see all of cosmic history and witness the cosmic creation event. And as you've heard from me before, our capacity to see all of cosmic history through our telescopes gives us the most compelling, rigorous scientific proofs that a God beyond space and time created the universe and designed it for the specific benefit of the human species. And this is something you see talked about in the Bible, many places, but let me give you a couple. Psalm 19, verses 1 to 4. The heavens declare the glory of God. Night after night they display knowledge. Their voice goes out into all the earth, their words to the ends of the world. Not everybody's got a Bible, but everybody can look up at the nighttime sky. And as they do, they see the revelation from God to humanity. And Psalm 97 tells us it's not just God's existence that's revealed in the universe. The heavens, the universe, proclaims his righteousness, and all the peoples see his glory. And so we'll be talking in future sessions about how we can examine the universe and learn things about God and learn things about ourselves.
Location, location, location. It's true in business, and it's true in the universe. As an astronomer and pastor, Dr. Ross did some pretty heavy lifting for us just now, including everything from dark energy to exotic dark matter. But for me, the real take-home message from this session is that we are nestled exactly where we need to be in this universe. A little to the left or a little to the right, and it would be impossible for humanity to exist on this piece of real estate we call Earth. The evidence is clear, and it points directly to the existence of a creator who has thoughtfully